Mic on. Yeah, so we're gonna look at this different today. If we have change in y is ut plus, yeah,
just say
velocity, acceleration due to gravity t squared. Then in the last second, so in the first 3 seconds, it would be y bar equals 0 times 3 seconds plus a half times 9.8 times 3 squared, which is 44.1, right? You brought your calculator today?
Yes.
All right.
The other day was such a painful day. What to explain like it? So it's a half.
Yeah. Times 9.8 times 9. And this is at 3 seconds, but we're also told that it equals the same distance for the last second. So I think the last second we can say t minus 1. Let's try that. Ooh, but we don't know the velocity there because it's starting at a different velocity.
Mm-hmm.
But we know the distance is 44.1 meters. All right. In 3 seconds. In 1 second. All right. So, but we don't know the velocity there. T minus 1 plus a half into 9.8 t minus 1 squared. I just want to see where this will take us. So if we have 44.1, oh, my bad. Today it's doing faster. Can you see? It's refreshing faster. 44.1 is v t minus 1 plus a half, or rather let's say 4.9 times t squared minus 2t plus 1. So vt minus v plus 4.9t squared minus 2t, or rather 9.8t plus 4.9 equals 44.1. Since this is in the last second, nah, this is just too long, unnecessary. I don't trust the ChatGPT answers though.
You see what I see here, what they did, man. They added the times.
Added the times?
Yeah.
So what do you think that does?
I don't know.
Okay. Because when you say they added the times, they added which time and which time?
They added the 1 second and 3 seconds.
In the progression of the drop of the ball, I don't think that makes sense.
Yes. But I think we can make this part n. Can say
we're here. Make it n.
Yeah.
Okay. And then say what?
I don't know if I'm making sense, but we can say 4 plus n, which is the total time it takes for the ball to drop from the top to the bottom.
Okay. So 4 seconds plus n seconds is the total time. Okay. I can take that.
And
equals 4 plus n. But we don't know what the total time is, right?
Yes, we don't know what the total time.
Cool.
And then we also don't have anything. We don't know anything
about here. That's fine. All right. ...44.1 meters in 3 seconds and another 44.1 meters in 1 second. We don't know how far it travels. But we know that the total distance must equal 88.2 plus a delta y. Okay.
Let's look at the equations and see where we can substitute.
If we take this height for the first 44.1 meters, let's call it y at 3 seconds, and if we take that height, right, and then add these two,
We add these two.
no, I mean add the first one and the one who we don't know. What would that give us? Okay, but we don't know what the velocity is here. Oh, but we did calculate it the other time. It was 29.4 meters per second, right?
Is it still the same? 29.4. Could it still be the same?
I would like to think so. I mean, but man, these guys did it without even looking at the velocities. Not even looking at the velocities.
That's the final velocity.
That is the final velocity. So let's say final velocity at 3 seconds is 29.4 meters per second, right? And then we also have,
which is this one's initial velocity.
which is this one's initial velocity. Let's just try that and see. So if we have that and we have this, maybe we could find the time. So let's say we have delta y at that point x. It would be initial velocity times time plus a half times acceleration due to gravity times t squared. We know that this is the 244.1 meters plus this y, and this would be 29.4 times, oh, but we don't know how long the time is.
It's n.
Oh, it's n seconds long. It's
the
4 plus n. It's
n.
Oh no, it's n. You're right. It's n. It's n. 29.4 times n plus a half into 9.8 into n squared. Okay. So we have 88.2 minus y bar equals 29.4 n plus 4.9 n squared. Then we have two unknowns. That's okay, because we can look at, or 4.
Can't we make the 4n negative 4 is equals to n?
Oh, no, I can't. Because we don't know what the total time is, so we can't work from there. But we can do something. I'm just not sure where my head is at now.
Can't you do simultaneous?
Yeah, I would love to very much find the second equation. Let's try the other equations of motion. It's V final equals V initial plus AT, right?
Yeah.
So GT. So where the final velocity is 29.4 and the initial velocity is 0, that's just gonna give us the first thing that we calculated, which was the velocity.
So now we're looking for the second equation.
We're looking for a second equation.
That will include n as well.
And y, yeah.
N and y. I was thinking maybe we can do an equation that covers the whole
How?
tower.
Okay. And you'd
Okay.
use that to work out what?
To work out, I guess we're gonna have y and then we're also gonna have n,
Okay.
which are our unknowns.
Oh, okay. So let's make this 1.
Yes.
And
we're
it's
gonna
for
have
the
a
middle
second
part.
equation. Yes. Gonna have a second equation.
And then for the total height tower, then we could have,
It's going to be 88.2 minus y,
yeah,
which is the middle part. Our values is 88.2 meters minus y, which is our total height. Our acceleration due to gravity is 9.8. It's going down. That's positive meters per second. And then our velocity. That's
something's
what
not
we
right
have.
here.
Wait.
If we're doing for the middle part, right,
Yes.
and the middle part is total height of tower minus 88.2. It should not on this page be 88.2 minus y, it should be the other way around. Should be the other way around. Okay, so we've got that. And now you're saying for the total height of tower, which would be y bar plus 88.2 should equal the initial velocity is 0 time plus a half gt squared. That's 0.
Our time is 4 plus n.
Total time.
Total time is 4 plus n.
Oh yeah. 4 plus n plus a half 1.8
4
plus n squared. Then, okay, that's 0. So it becomes 4.9 n squared plus 9.8 n. That'd be 4.9 times 4 times 2 is 9.8 times 4n. What's 9.8 times 4? Wait. I might be doing something incorrect. So it's 4.9 into n squared plus that is 4 times 2. Yeah. I guess that's the correct procedure. So you say this times that multiplied by 2, right? When you are expanding a binomial like that.
I will do it like 4 is in right. It's going to be 4n squared, 4 squared, and then it's going to be 2 times n times 4.
So it's going to be 8n. Yeah.
8n
Plus 16.
plus 16. And then plus n squared.
Okay, cool. Then we've got 9.8n squared.
So where does this one come from? Because we haven't multiplied it.
Oh,
So I think you must remove that one before
before I carry on, eh? So it'd be
4.9 n squared.
plus what's 8 by 4.9? That's 16, 24, 32. It's like 35 point something.
39.2.
39.2 n, and what's 4.9 times 16? Should be 80 something.
78.4.
78.4.
Yes.
And this equals y bar. That's 88.2. Then y bar. What's 78.4 minus 88.2? About negative 10.2.
Negative 9.8.
Negative 9.8.
Yeah.
Okay. 9.8. It's 4.9n squared plus 39.2n. Okay. We've got our second simultaneous equation there. How about we substitute this into there, and then I just want to do this. I just want to grab the screen so you can refer to it easier. Just capture. So open it. Yeah. So I'm gonna do this. So now we've got 4.9n squared plus 39.2n minus 9.8 minus 88.2 equals 29.4n plus 4.9n squared. Well, these two are equal, because whether you take the additive inverse to the other side will give you 0. What's 39.2 minus 29.4?
39.2
minus 29.4.
minus 9.8.
9.8n. And what's this? 9.8 minus 9.8 minus 88.2.
Minus 98.
9 minus?
Negative 98.
Oh, okay, so it becomes 98 because the negative going to the other side. So at n is what's 98 divided by 9.8? 10.
Could be 10 seconds.
N is not really a measure of, so 10 seconds. Wow, okay.
So it's 14 seconds in total.
So the total travel time is 14 seconds. Interesting. Now, let's use that time to work out this distance y. So
This is substituting here.
we can substitute, yeah, back there. So we'll have, if n equals 10, therefore y bar equals 4.9 times 100 plus 39.2 times 10 minus 9.8, and this is 490 plus 392 minus 9.8, that's 782, 882, I think. It doesn't seem right. If you add
I got 872 minutes.
And what's our answer? 123 meters. Nah, B.
Oh my god. Oh, guys.
Nah, that's why I'm like, this is... Okay. We can try this
But
again.
the concept was... We had a good concept. Like,
Yeah, we did.
what we were thinking was correct. The outcome was the one that was not correct.
The common difference between the time is 1 second. Alright?
Okay.
So 1 second time intervals between, I guess, the timing. At the last second here, TL, right? A second before then, we have whatever the time is, minus 1. A second before that, we have whatever the time is, minus 2. And so on, in that order. Right, ascending. How do you express the total time in terms of okay, so I want to think about something close to what we learn in sequences and series, you know what I mean? But I also want to say let's start from scratch. Tower, ball, and it drops, right? Let's do it piece by piece. First 30 seconds. Okay, so at t equals 3 seconds. Okay, so we know now the facts, right? What we can also confidently say, this is correct, is that at t equals 3 seconds, y bar is 44.1 meters. So that we can comfortably work out. Sharp. What we don't know is what the distance is for the last second, and we also don't know what this distance here is. So y bar is unknown, y bar there is unknown. We know for the last second, t equals, the size of the time is 1 second, but how can we express it generally? And I think that's where this thing comes into play. This here, that's where that comes into play. In the nth second, the distance is y subscript n, right? And it also equals, but if the time at t at the nth second, why isn't that featured here? That's my question. Why isn't that featured there? You get me?
Yeah, because it's supposed to be there.
Supposed to be featured there. We don't have an equation of motion that just has a velocity standing alone like that. We don't.
No, it's either it's velocity squared.
Or the acceleration due to gravity times the time squared or something like that.
Yes.
So now I'm thinking,
Oh, we do.
which one is that?
Oh no, it doesn't.
But it's not like this.
Not like
Yeah, that's what I was saying, correct. But this equation doesn't look right.
that.
This equation I think needs to be interrogated. Okay? Because in the nth second, if that is t, then that must also be ut, and that t must be multiplied by that, and we should have a square there. I think that's because the solution says y equals u plus g over 2 times 2n minus 1, which is distance covered in nth second, right? But I think that this equation is not entirely correct, for the simple reason that doesn't look so right.
It doesn't make sense.
Doesn't look right. I can understand losing the ut part if the initial velocity is 0. You know what I mean? That's perfectly fine.
This is what it's supposed to be.
Yeah, like this. So that one, that's why I said this one we can comfortably work out, and that's fine. So we've got the stats for it. At t equals 3, the total height is 44.1 meters. Now, let's try and find, because I think the textbook might not be too far off suggesting that there is a height covered in the nth second. And I think there is some meaning to that. Right. So let's assume there is meaning to that. Then what that means for us is how can we define the general case for the time traveled? That's where we should start. We've got our first second, it's a, it's 1 second. T2 is 2 seconds. So it's a plus 1. T3 is a plus 1 plus 1, right? This is okay, but that's just gonna give me to conclude no, something is not. You know what I'm trying to get at? Think about this now. I'm trying to get at, as we increase the time, how can we explain that increase in time whilst having something like an unknown like that? So in other words, to say Tn equals a plus n minus 1d. Okay. So we've got 1, we've got n minus 1, and our common difference is 1. And this would be 1 plus n minus 1, which is n. Okay. It just tells us that in the nth, Okay, but now I'm really starting to ask myself, why for the nth case they say 2n minus 1? Because what we learned from sequences and series just tells us, hooray, the general case for the time is just n. And you just increase it. Okay, let me answer this time.
I want you to buy something.
Yeah.
You know what's crazy? My phone doesn't take those calls.
Is it? So it's got like a spam detector app or something.
I don't have an app. Like, since I don't know when, but like.
Maybe your numbers are not yet shared with people who sell these things. Okay, so why?
This would only work if our first term was 1. If we're going to use the arithmetic formula,
yeah,
it'll only work if our first term, if our A is 1.
is 1. But our first term for the time is 1. Isn't it? No, it's 0. Here's the thing. So we have there t equals 0 at the top, and then here t equals 3 seconds. Okay, so I guess... No, but our velocity increases, or rather our time increases in increments of 1 second, which is pretty much...
What I'm trying to say is that I only get 2n minus 1 when A is 1.
When A is 1.
Yeah. This is the only time I get.
How did you get the common difference of 2?
I was just guessing.
No.
So I'm trying to figure out what could be
the reason to make it 2n minus 1. I also don't get it, so I don't want to fix too much on it. But what I would love to see is... What is the height at t is 2 seconds? Within these first 3 seconds. It would be 0 plus a half times 9.8 times 4, which is 2 times 9.8, which is 19.6 meters. Okay, but that doesn't really take me anywhere. But what is the height at 4 seconds? A half times 9.8 times 16, which is 8 by 9.8, which is 8 times 9.8. How much is 8 by 9.8? 8 times 9.8. That'd be 78.4.
I didn't believe it. I don't believe it.
At 4 seconds.
That's at 4 seconds, right?
Yeah. So that's like 1 second after, maybe somewhere there. Okay.
So let's do it until we get until we get 123 meters.
I'm not really sure if the 123 is even correct, but let's just work with...
I don't think it's correct.
Let's just work with...
The other one is 122.5.
Which one is that?
For 5 seconds.
For 5 seconds. Okay.
6 seconds, 176. It says
Okay.
here the total for at 5.01.
Seconds, yeah. That's
122.
120, yeah. But what we don't know is how long the drop is. We don't have the total time of the drop. Instead, we have 3 seconds, a gap, and then 1 second. But we know that in the last second and in the first 3 seconds, the drop is the same. But can't we find
123 minus 88. 34.8.
34.8? I wanted to think of, so we've got y equals 44.1 meters at t equals 3 seconds, and we also have 44.1 meters for the last second. The last second would be, we don't know what the last second is, so let's just call it t. But in the time traveled for that last second, it's t minus 1.
Okay.
So if the last second is the 9th second, then the time traveled is 9 minus 8 seconds. Sorry, 9 minus 1. The total time travel would be 8 seconds. But that 1 second would be the 9 minus that entire thing.
So it means our answer when we got 10 seconds wasn't really wrong. Oh, it was the word.
It was a bit far off though.
It was far off.
But now we have the second half, which is ut plus a half gt, right? And in this case, we know that our time is that, so we'll have v t minus 1 times t minus 1 squared. This equals 44.1 meters. So we'll have 4.9 times t squared minus 2t plus 1 plus vt minus v equals 44.1. Okay, so I've just expressed this other equation in terms of v and in terms of t. And we've got 4.9t squared minus 9.8t plus 4.9 equals vt minus v, and this equals 44.1. I want to group like terms, so we'll have, let's say 0 is 4.9 t squared. Minus 9.8 t plus vt, and then plus 4.9 minus v. Okay, and this is 4.9 t squared plus v minus 9.8 times t plus, I guess, 4.9 minus v. So this is what I've come up with, right? So using that theory to say the last second is expressed as t minus 1, that time frame. Okay. So we leave it at that. Remember here somewhere we've got a velocity. We work that out as 29.4 meters per second. meters per second, but we don't know the velocity here, and perhaps we could use that velocity to work out as an initial velocity. Oof, but what's the final velocity here? We don't know. Ooh, so that's not gonna work.
Turn off this equation.
Okay, I wanted to find another equation so that it's a lot more possible to solve simultaneously for t and v. Huh. Okay, we're probably not that far from the answer or from getting it. But what I do think we could do, if VI is 29.4 meters per second, VF is unknown, Y bar is VT plus and I still keep thinking the same thing. There is some sense to finding out the general case for the time travel, you know what I mean? Because if the last second of travel is t minus 1, then the last 2 seconds of travel will be t minus 2. And the last 3 seconds of travel will be t minus 3. But now how do you make that general? Generic. Two n minus 1. Okay, so let's say I have. What am I not thinking about? What are we not thinking about, Joy? What are we not thinking about? So let's say we've got okay, let's try something else. Remember they said in the solution, let me just clarify. In the solution, they use the formula yn is u plus a half g times 2n minus 1, right? Let's just say this somehow we figured it. This 2n minus 1, we figured it. But instead of applying it to this formula, let's apply it to the actual formula. Plus a half g t squared, so that we have 0 plus 1 over 2 times 9.8 times 4n squared, that's negative 2n times 2 is negative 4n, plus 1, okay, and this is going to be 4.9 times 4n squared. Let me just show you here. Times 4n squared minus 4n plus 1. Let's say that's the case. Then we'll have, what's 4.9 times 4? It's 18, 19 point what? 19.6 n squared minus 19.6 n plus 4.9, right? And then this is y at the nth second. Okay, if that is y at the nth second, in the last second, which is the same distance covered as the other second, so it'd be 44.1, should equal this. And if you put that 0, we'll have 19.6 n squared minus 19.6 n. What's 4.9 minus 44.1?
Negative 39.2.
0.2. Can we use quadratic? It's b squared, right? No, it's
it's
negative b.
Negative b plus minus root of b squared minus 4ac over 2a.
And we'll also do for minus b minus b squared minus 4ac over 2a. And the first one will give us how much? How much you get?
This can kick me out of the
Hmm? That's a positive one.
Positive.
Just gives us 2.
2.
And then the negative one?
Negative 1. Negative 1.
Negative 1. No, this can't be.
This is like foolish.
No, this can't be. No, this can't be. So now I'm confused.
I think that I didn't square it, and I did.
You think you didn't square
I
something?
thought I didn't square something. That's why it's 2, but I did square everything.
Everything. Okay.
So let's see.
I don't think these are correct. Huh, okay. What happens if we do that which ChatGPT said, which was y equals v t plus a half gt squared minus maybe not that.
That's the for the root. For the root of negative 19.6 minus 4 19.6 minus 39.2 will give me 58.8, which is the answer I also got here.
When you first started. And when you asked the AI.
Yes.
Okay. So, my worry is what if we equate directly? Like we're saying at the last second, the thing travels t minus 1 second, right?
Yes.
Alright, cool. So if the thing travels t minus 1 second, this is in the first 3 seconds, and this is in the last second, right? So the distance traveled must be the same. If that is the case, we know that that's 0, or rather we know that this is, no, okay, let's do this. I just had another thought. That 44.1, which is the distance traveled in the last 1 second, and is the same as the distance traveled in the first 3 seconds. If we use it to find the initial velocity, what would happen? And that would give us this velocity here, at this point here. It will give us that velocity. Let's try that. So 44.1 equals v, let me just say t minus 1 for now, plus 4.9 into, right, v t minus 1, 44.1 over 4.9 t minus 1 t minus 1. Alright. Then v would be 44.1 over into t minus 1 t minus 1 t minus 1. Okay. Then this doesn't look like it's taking us anywhere, man.
No. It's even slowing us down.
It's even taking us way out of bounds. Yeah, you're right. I thought if we equate that distance traveled to the second equation, what are the other equations again?
It's VF, which is supposed to be initial, like plus acceleration.
Okay, we don't want that. The other one?
And we have the one
The other one is VF plus VI, ne?
VF squared is equals to V initials.
What about that one? We have this, right? It's like that. And the other one is V squared final equals V initial squared plus 2GT, right?
No, displacement. Change in displacement.
Oh, change in displacement. Not bad, not bad, not bad. So it'd be delta Y. And you want to avoid at all costs having a formula with V. So that's why this is not gonna work. So I'll go back to where I was going with my other thought. Let's go back here. We shall go back here. Nah, it's not gonna work either. Oh my goodness, what are we not seeing? Joy, what are we not seeing? It has to be another way. It has to be a different way. It has to be a different way. It has to be a different way.
What does all these excuse me, my friend. Anyways, all these answers that we got from ChatGPT,
Yeah,
what do they have in common?
we can check that. Ooh, it just keeps refreshing. Oh, chat. Archive chat and settings. Archive chats. An archive. But I want to see everything. So when I hit refresh, oh, yeah, there we go.
You must have something in common.
I think they do. See, this is what I was wondering. Distance covered in the last second is the total distance. Okay. Maybe that's what I wanted to contemplate. Okay, I think this formula has some sense to it. Because this first part calculates the total distance of the drop, but we don't know the total time. But if we were to account for whatever the total time is, minus the last second, then the whole expression, but for t minus 1 would apply. So I think there's some sense there. I think there's some sense there. So what does this thing say? Oh, so we can equate the distances covered in the first 3 seconds and the last second, but we can't equate the equations. This means no, but we can. Or maybe we can say, instead of 44.1, we just say V T is half G T squared Then at 3 seconds, and this is v times t minus t minus 1 half g t minus 1 square. That's 0 plus 44.1 equals okay, so here it says to equate the two distances so you can solve for h, but I'm unclear about something. Why for the last second some of these terms that have u fall off? Do you assume the initial velocity is the same as when the ball was dropped? Is that correct?
Doesn't this multiply our?
The u ought to multiply the t and the negative y.
So we're going to have negative ut that subtracts each other.
Oh, so they do cancel each other out. Good point. Good observation. Vt is half gt squared minus is vt minus v plus into g t squared minus 2g plus 1 t squared plus half gt squared minus vt plus v plus a half g t squared plus gt plus a half g plus 44.1. But now, remember that ut you mentioned, corridor multiply and. Okay, so it's ut minus u. I get it's ut minus u plus half times acceleration times t squared minus 2t plus 1. So I've been doing the calculations somewhere here. It should show up. There we go. So that's that. This times that is that. Oh, I'm supposed to get a negative there, isn't it? Yeah. And if that's minus gt times, then I get a negative there. So then that means this should also be a negative there. Correct? Is that correct? Let's check.
Right here.
Yeah. I get it. It's half gt squared times negative gives me that. Right. And then half g times negative 2 will give me negative g times t will be negative gt times the negative there will be plus gt. And then a half g times positive 1 is positive half g.
Yeah.
Times the negative there will give me negative half g. So that's correct. Alright. But now, that thing you said for the things cancel out, I think ChatGPT made an error there. Because let's put some color on it. These two are like terms. So they're also additive inverses, and they'll cancel each other out to give us 0.
And these two as well.
Yeah, so we're grouping like terms. So these two will cancel each other out to give us 0. And it appears we're left with just
GT
44.1 equals V plus GT minus a half G. Yeah? And then we have 44.1 equals V plus G into T minus a half. Now we've got our own equation.
Great. Let's substitute.
But now,
Substitute acceleration to get home.
okay.
Let's
But
make
we
this
won't
complicated.
know what V is. But we'll know what V is after. But we won't know what T is. And V.
Oh.
We won't know what V is and
God
what T is.
forbid this thing comes into the exam.
I doubt it will. Doubt it will. But I don't want to be so confident to say it won't. Because I am not the one setting the paper. You know what? I'll need to ask friends. I have to touch base with my former science teachers, find out if they can help out with this. That'd be great.
Get in touch with this self, like
Yeah, definitely.